Good afternoon, everybody. My name is Tom Nato, and welcome to the Net Podcast. Today, we have our special guest, Chris Wright, who's the CTO at Red Hat, otherwise known as CDub, to a lot of you out there. And as always, Mr. Tucker, Mr. Salisbury, and Mr. Mestry are on with us as well. And today we're going to talk to Chris about all things open source networking. So welcome to the podcast, Chris.
Thank you.
Give yourself a little intro.
So, well, I'll do my best. I love open source networking. I love you guys. So how could I say no to hanging out with you guys since we're not at a conference at about shutting down the hotel bar reality strikes at that point.
Never done that before, right?
It's still nice to hang out. So I appreciate the opportunity. Thank you.
Yeah, thanks for being on. So let's start things off. We've got a couple of questions, and we'll see where we go. I guess when we talked about having you on a couple of weeks ago, really the first thing that came to mind was your past history as a Linux kernel developer. And then how that evolved into your sort of getting involved in networking and now heavily involved in the open source networking thing. So you want to give us a little bit of retrospective on how that went and all that?
Sure. So I'll go back a little ways. In the beginning of my career, I actually worked in telecommunications. I worked for a company that provided solutions to service providers, and I was buried in SS7 protocols and white book, blue book. The beauty of standards is you get to choose from all the standards, and that wasn't very open source oriented, not just the industry, but the company that I was working for, except for the tool chain. And I actually left that really with enthusiasm because I was bored and I wanted to do something quite different. And I had Linux running at home, and Linux was like a hobby thing. And
yeah, it was still pretty nascent then. Like what year roughly was this?
Well, we did have electricity.
Just for context.
So.
Yeah. We had combustion engines, but just
like
for context.
Mid 90s.
Cool.
And I had Linux running at home. I was responsible for high availability, and the HA world has things like proxies for load balancing. Familiar, it's not new. And so because we're in the telecommunications network, there's a big networking component to what I was doing. I left and was able to work for a company focused on Linux. And it was that job, based on my Linux HA experience, it was that which they hired me for, which I never actually did, which is oddly a recurring theme in my own personal work history. That job, I switched gears after I started, so I no longer did HA, and I started focusing on security. And the security work that I was responsible for was actually creating network permissions for a host as an endpoint, not firewall, ACL's world, but host as an endpoint, the host applications, and the applications access to the network. So I was buried down in the kernel doing something that ultimately became the Linux security module infrastructure. And I was working on a project that we called Subdomain, which subsequently became AppArmor. And AppArmor and SE Linux are the two best known implementations of the Linux security module infrastructure in the kernel. And I came into that through networking. And turns out a couple of things were really interesting in that context. One, it's hard to disambiguate an application or a socket from which application it belongs to. File descriptors can be cloned or duplicated. and even passed around. And networks don't expect certain types of, especially TCP, don't expect certain types of out of flow responses. So you can wedge, especially middle boxes, in interesting ways by just generating the wrong packet at the wrong time, especially in the late 90s when the world was not as sophisticated as it is today.
Yeah, the whole
so I kind of came into it through that.
Yeah.
Through that world.
Cool. So security was kind of the gateway drug to networking. Is that what you're saying?
I don't even know what is the gateway. I think maybe high availability. And the thing that's interesting there is in my career, I've worked on distributed systems and high availability. I've worked on security. I've worked on virtualization and cloud. And the HA proxy load balancer world is something that you use not just for availability, but it's a virtual IP. You're virtualizing access to something. And that brought me into the Linux vServer project, which was really basically today's containers, but in a much less sophisticated way. And the Linux vServer project brought me into virtualization. Virtualization brought me into the cloud. And the vServer thing, IPVS, IP Virtual Server, the vServer thing had a networking focus, and I was using vServers for security isolation. So, the point is, all of this stuff I think is interconnected, and it's
kind of lined up. Yeah, it is. Yeah. And so for folks listening, this was prior to libvirt, right? This was
libvirt did not exist.
Did not exist. The thing people think is KVM and everything today. This is.
Yeah, there's a couple of interesting things too. All of this. It's interesting that load balancing did this for you, because over the last few years, look at the world of load balancing, right? And the interesting projects, whether it's Facebook's load balancer or GitHub's that they've released. Load balancing is still a super interesting problem. And there's all this interesting, innovative work going on even now.
Well, it's critical also for Kubernetes. The whole scale model is predicated on proxy and load balancing, right?
Yeah.
And it's still a disaster.
Wait, load balancing or Kubernetes? I wasn't sure what you meant there.
Well, no, I do, jokes aside, the amazing thing is security and APM or whatever we want to call the application delivery model is still the most important thing. So, even 20 years ago, the value was seen, right? And then in the meantime, we've been figuring out, reliable ways to get packets from A to Z. But I still think the value prop of tying the applications back to the network is through security and application delivery. Is that what you're seeing, Chris? Or I guess you've always seen it.
Specific. Yeah. I'm clairvoyant in the future. In a very specific way, 100% what you said, Brent, because the network is the computer, that's 30 years old now or more. So these aren't new ideas. None of these ideas are really all that new. The IT world's great at recycling good ideas and moving back and forth between two basically extremes. But in the context of networking, it clearly isn't just connectivity. It's also exposing something. That's the connectivity piece. And when you expose it, you have to ensure that you get the right access control rules around what you've exposed. And the old school sort of perimeter firewall world worked well in a time when you had kind of minimal surfaces exposed. When you take an application and tear it apart because monoliths are evil and microservices are awesome, you really tear an application apart and expose its internal APIs.
Surface area. Right.
And only sane way to do that, first of all, the only way to make that work is you got to reconnect it through the network. So the network becomes literally a fundamental part of the application. And then the only way to make that work safely is really careful controls over who can speak to whom when you're accessing APIs, which maybe could be externally accessed, but in practical reality, they were probably designed initially, especially if you're migrating a monolith to a set of microservices, built in initially with the idea that it's never exposed. And so I think they're very related. Security, network connectivity, availability, they're all variations on application resiliency and making stuff work.
And do you think that's kind of like like just jumping ahead to today, I mean, that is a big challenge we have, is converting, I don't even want to say legacy, because some of these things are a couple years old, right? Is converting a virtualized thing into a containerized thing. And it's not like you said, I mean, there's actual fundamental things you need to worry about. It's not like you just shove it in a new box and say, off we go, right? I mean, there's a lot of this stuff, right, that you have to worry about.
And just that disaggregation that Chris describes is monumental in task, right? I mean, you just take an average enterprise, they manage a firewall with 10,000 rules in an access list. You're now going to take that and exponentially grow it by disaggregating it across all the nodes in your cluster. I mean, the opportunity of kind of the zero trust model is amazing, but it's also like there's a lot of work there.
Without a doubt. And reasoning connectivity in the end, like it's I think we grew up more around a north-south boundary, and as you open things up and focus on the east-west traffic, it's just a whole world that the industry doesn't have as much background and experience in. We're applying the same tools and techniques and experiences, but we're trying to solve a slightly different problem. And it's really clear when you put everything on a public cloud. The only way you get access to things is through a public IP, and the models that we're learning through that software architecture carry out through into the enterprise.
Yeah,
and it's a hard thing.
All those APIs are only accessible through a network connecting to that thing, right? Yeah.
Right.
I've got some serious nostalgia for the good old days when, applications expose one port and we used to have firewalls and DMZs and everything was really easy. Now with all of this disaggregation, like things are getting wild. I mean, Kyle's now the expert on service mesh, which is interesting territory. But I think probably one of the key things that you mentioned, Chris, is cloud and how that's changed everybody's attitude to everything. Because before east-west traffic, it's all fine, right? It's all in our own network, and we can be lax because we control that. And when that's no longer under our control anymore, then that has some interesting implications from a security standpoint.
Yeah, absolutely,
no, for sure.
I actually like the cloud for that. I mean, for a number of reasons, but for that reason specifically, which is the hard on the outside and soft in the middle security model is sort of broken by design, in my opinion. And so really forcing you to think rigorously about all connectivity, which we already knew was problematic. We just created some we trust our people and head in the sand a little bit.
Well, you just said it, right? Like if you have a disaggregated app and pieces of it are on one side of, in the GUI middle with that perimeter fence model, and then another part is somewhere else, your trust model is a little different. It's then the whole app is inside of my ring. In fact, I agree with you. I mean, even when you're inside of the ring, you're not as secure as you think you are, because that's a, once you make it through the paper wall, you're in there. So securing every single nugget in the microservices application architecture is critical, right?
It's
great.
great.
That whole thing work.
This is where we blame Nat and plug V6, by the way.
Right.
I just had a flashback to maybe 10 years ago of trying to talk to an application team about an application we were trying to secure. And it was like, so guys, how does this work? And they're like, well, we've got these things and these things talk to each other. Cool. What port? We don't know.
We don't know.
Okay,
we hard-coded IP addresses.
What protocol? Oh, we don't know. Like it's all fine though. It's all in the middle. And now making that incredibly explicit in this microservice world is Good.
But it's that drives network operators bananas, right? Now they don't know what to control and where. Like Brent's model used to all go through a straw at the end of the network, and now I don't know, right?
It's all
Well,
chaos now.
this is what zero trust is going to solve for us, though, right? So we're good. With
Great, let's go home.
Ding,
Yeah, right.
Done.
drink.
Check.
Problem solved.
well, yeah, that's all right.
But I
That's
think like,
All right, see you guys.
but we're not changing just to change in this sense. Like with SDN, I think I was as guilty of this as anybody, right? Like I'm tired of black boxes. I want to rip them out and I want to put in like generic boxes, and I'm going to save money that way. With the security and arguably the application delivery side, there are concrete benefits, right? I don't have to wait 2 weeks for a firewall entry to go through change control. I don't have to every time a new project rolls in, am I going to be worried about hitting scale on my north-south security model because there's a box there that may be, that we scaled 4 years ago and it may be out of computer memory to push those lines. So, it's the scaling of we're trying to scale network the same way we scale compute. I mean, that's fundamentally one of the things that I learned from Chris long ago is like stop thinking about network devices as, special, network devices. They're Linux boxes.
Or a special
Start
physical
treating
thing
it as
even,
compute.
right? You can have
Right.
virtualized versions of all of those components now everywhere. Right. Yeah, I mean that's kind of the irony, right? Like we're doing the load balancing stuff we were just talking about in proxying to actually enhance scale, but it introduces new problems. It's that, there's no free lunch category, right?
Called
Cool.
progress
Yeah, that's progress.
or job security or one of those.
Job security.
That we're in the IT world in general, networking is no exception. We're so vulnerable to like hype and buzzwords and all this stuff, and it does create work for the sake of work. Like just pad your resume, become the expert in the thing. But even SDN, while it had a major hype factor, that same firewall issue and waiting 2 weeks for that same team to give you an opening in a firewall for a port and application that's running virtualized on your infrastructure, that was a problem we were trying to solve with SDN. Yeah. And so I think in a real way, none of these are brand new problems. We're just everything's changing. The way I think of it is we're on this hamster wheel and you're running and the scenery is changing as you're running, but you're actually still running in place. Because we're everything is always changing, and it's maybe a little bit of a sad thought when you think of I'm painting the Golden Gate Bridge, and the minute I get to the end, I'm going to start painting my way back, and you never finish. But it's also partly what's fun. Like everything is always changing while we have some of these basic ideas. So programmability is not a new concept to the network at all. It's just exactly how you do it and from what context and with what speed. So when we were talking about static servers, we had programmability. That was probably best used to inhibit error introduction from humans. Not so much about a speed thing as much just like don't screw it up because when you type, you're going to fat finger something. Get to virtual machines and you get a slightly different world where the scale of change starts to outpace how fast you can type on the keyboard. And then when you move to microservices and containers, it's untenable. There is no choice other than programmability in the network. And then, we have all these other side effects that we're chasing: scalability, better security. But again, I think they're all interrelated, and I think that's why it's fun. I mean, it is a little bit of a perpetual journey, but hey, you learn a lot along the way.
Well, part of it too is like you just made me think about way back when NetConf was still pretty nascent, and we were talking about replacing SNMP with it. And I remember many people making the argument that NetConf is actually it wouldn't work because it was all text based, right? It's not binary, transaction. And it was right on the cusp of what you were just describing, right? Where we just went, it doesn't matter anymore. It's so much computing power that, you know, it's actually better to make it less efficient. But it was because humans can read it and work on it, but then it's also easier to manipulate later. And it's kind of two things you were talking about. One was like rediscovering a new solution to the same problem that actually is better, but it had to be unlocked because of the changes in technology, right? Yeah, I distinctly remember standing there at an IETF meeting and people shouting at each other about this. And, you know, Keith McClory was there and going, well, you know, binary, it's got to be binary so that, you know, X, Y, and Z works, whatever. And the NetConf people were like, no, it's fine. You know, and this was even, I mean, it was XML, but it was, geez, what was the original one? It was Beep or SOAP. So it was even 3 progressions behind what we have today, you know, and we still were like, hey, you know, maybe there's an idea in here, you know.
But I think fundamentally the other thing that Chris brought up was, you know, SDN as a concept. I think it's almost the default way of thinking about networking programmability. I mean,
today, yeah,
it is, right? And so regardless of what it looked like 10 years ago or 7 years ago or 5 or 3 in whatever form, whatever project we were all working on, I think all of that work drove the industry to where it is now. And the fact that it's programmability is the default now, I think a lot of people might take that for granted, but that was like 10 years.
But you come out with a device today, like Nick said this
Yeah.
when we were on with Nick the other day. You know, he said, you come out with a device today that isn't programmable straight out of the box. What are you doing? You know?
Yeah.
I mean, and he's right.
Doorstop.
Yeah. It's a heater for your house or whatever. I mean, even these crappy little switches I have now, these like $100 Ethernet switches are programmable. They have REST APIs you can talk to.
Yeah, and it's not just the devices. I know. So a good friend of mine that some of you are familiar with, Mr. Andre Tunk, he likes to phrase it as it's KV based networking, right? Key value based, right? Because really a lot of what we're doing with this, you get a KV store and you get a message bus, and you can like do some pretty interesting things with the networking world. So.
Yeah, it's a different way to solve problems now and it's kind of like we were saying. So Chris, have you seen any other, like in your, like back to your kind of career progression thing at the beginning of the conversation, like have you seen any of those inflection points that are very interesting besides SDN or even within SDN?
Well, I cite SDN as a point in time that had 2 things happening at the same time. One was total focus on programmability. And, you know, at that time, OpenFlow was a big part of the conversation, which I always felt was a useful way to articulate the implementation details, but not the only way to do it. And I still feel that way. But what OpenFlow brought into the conversation, along with SDN and programmability, was a open source and implementations around SDN. So the white box discussions, disaggregation at that lowest level, a lot of conversation around that in those earlier days. And what I think, as you know, that created that inflection point for now, it's just a normal part of the conversation. It's not weird or unusual to say open source and networking and feel like you're groundbreaking with your ideas. You know,
right. 10 years ago, you got laughed at, right? You know,
yeah.
the usual big vendors were like, really? You know, that's all, they're toys, have fun.
It's still
now it's on par with everything.
It's not all gone away, right? And we'll be talking about how open source can take over the world for networking for another 10 years, and we still won't be done. But that sort of fundamental attitude and expectation, industry expectation, starts with what's the open source implementation, what are the projects that do that, and I think that's fantastic. I mean, I love open source. I'm hard for me to not be in that camp. I think that's fantastic, and I still look forward to the days when it's just standard hardware and Linux and a collection of open source protocols creating network connectivity of any type, and we are a long ways away from that. But I think that I think we changed the industry in that sense. I think we changed the industry by creating that conversation.
And that's an important inflection point, right? So like you remember, gosh, I don't know, it was when we started working on Open Daylight, I don't know, 4 or 5, whatever years ago. You remember how the conversation with operators changed? Now open source is a requirement on RFPs,
Yeah.
and that's kind of where all right, success, right? Now they're putting their money where their mouth is,
Yeah, absolutely.
and we're seeing that all over the place now with, different virtual vRAN projects and things like that, where open source is the heart of the thing, the whole thing. Well, a lot of the whole, a lot of the thing, right? You still have proprietary workloads and stuff, but like 80% of the system is open source. Like it's what you described. It's almost that picture you painted, right?
The picture that I like, it's in my head, is the network functionality, the software processing, protocol headers and forwarding packets, and all the stuff that's important at that networking layer. Those are potentially components that sit in or near the operating system, and it's just a part of the platform. It's not some special thing that sits outside or is on the side or is vendor provided. We spend a lot of time creating clever hacks into our open source orchestration platforms to allow for multiple vendors to bring in a vendor specific solution, when in the end, I think it should all just come down and be more a part of the core platform. Certainly load balancers and ACLs and routing rules, everything that's going to direct traffic and filter traffic. It just is so fundamental to how we connect, not just the orchestration tier, which is a cluster, so it needs its own connectivity, but the applications that it's supporting, which are all distributed. So they all need the same type of base capabilities. And the world is going to keep changing. We're starting to run out of CPU horsepower, so that those applications might not always sit in the same location. They're probably going to start getting stuffed more and more back into hardware. So we spend all this time hoisting it out of hardware, sticking it in software. We're like, it's going to be awesome. Like, oh, yeah, we ran out of hardware capacity. We got to
go back to hardware.
We got to start stuffing it back into special purpose hardware, which is part of just the industry pendulum swinging, and what keeps us perpetually busy. But it's real. Like, why are we doing that? Well, we're generating more data, and the applications need more of the CPU because they're doing more data processing, and we don't want to put all the CPU to just pushing packets around. And by the way, you can be really effective with special purpose IP blocks in hardware. So it's an interesting world, and there's places where I think we can take software and push it closer to hardware, or even into hardware. But that notion that it's just a platform capability and it's done in collaboration with the broader community, and that's the power of the open source model, I think that's what we're trying to build towards. And we're probably
that's another very cool part, by the way, that you just touched on. Like, many of us, all of us here, I think, have done some bit of standardization work prior, in the past. And the goal of the standardization thing was just to prove that functionality was compatible or so on. But we've gone a step further now, and we've said the 80% in the middle doesn't really have differentiating value anymore. It's just there, and so let's stop fighting about that, and let's compete around the 20%. And that's kind of what you just described too, is the standards thing. That's one of the other inflection things. It's not that some people like to say standards are useless or whatever today. It's not. It's they've evolved to hover around the open source core, so to speak, of these projects. And I think that's another important change that's happened too. We used to actually try to design the whole damn system in a standard, and not the best approach. Yeah, how'd that work out? Yeah, let's not throw anybody under the bus, but and today what we do is we use it as more of a tool around that model. Like it's kind of like we're not doing it just because to do it. We're doing it because we realize there's actually a better way to do it.
I don't think standards go away, and you got to, at some point, you got to put down on paper you put some rigor into it, put it down on paper how it's going to work, and especially at a protocol header level. I mean, that's hard to get away from. But the notion that we all have to build it ourselves, the standard is there to like force interoperability, that's a huge waste for the industry. That means everybody goes and rebuilds the same thing with some nice spray paint on the tin that you wrap around it, so it's truly differentiated. But we just don't need to do that anymore, which I think is awesome. And I think open source and Linux and open source networking has really changed how we collaborate, which means we can change which problems we focus on.
Yeah, I mean, to me, what it amounts to is like we've taken that 80% of people who used to work on things that 80% of other folks at other vendors were doing, and that vendor and that vendor, and just taken that whole group and said, you can innovate on some really interesting stuff. And, you know, Linux can be the operating system for the machine, but let's build a better load balancing service or something. You know what I mean? And I mean, we've all worked at places like that where there's an army of people building an operating system that the people across the street are building too, it is marginally different. I wouldn't even say better, right? Yeah, I mean, that's a cool thing too.
I was trying to figure out the formula around about December time when I was searching for my next gig. I was interviewing various places and I was trying to figure out once an engineering team reaches a certain size, probably like, I don't know, 1,000 people, at that point, the team starts developing its own tool chain. Doesn't matter what's available in open source or, you know, what everybody else is using. And you end up with like this tribal knowledge appearing of all of this stuff. You know, we built this because we wanted to do it this way. The open source thing did it this way, but no, we wanted to do it like this. And you end up creating all of this institutional knowledge. It's kind of crazy to watch big companies and big systems do that.
And it's stuff that you can either get most of off the shelf upstream and participate and make a little better.
Right.
You know, that there's probably another 1,000-person company out there doing the same thing. And if you were smart, you'd use your resources to innovate around them.
We built our own revision control system.
Yeah.
Why?
You know? Yeah, exactly. No. We got, I don't know, maybe like 5 more minutes left on the time thing. I mean, we've got a whole bunch of topics. You know, we could talk to Chris for the next 3 hours, right? But Chris, is there anything like near and dear to you that's really interesting, that's top of your mind right now, that's interesting?
Well, I'll go on a monologue. You interrupt me as you feel so fit. There's not just one thing. There's too many. But maybe it's, where am I spending my time? Put it that way. Spend my time looking at the edge as a concept, which is a buzzword. I really make fun of myself and say I'm buzzword compliant because I spend a lot of my time in the buzzword space just by being a technologist and doing technology strategy. Edge to me is about distributed systems, which by their very nature is about networking, about data, and bringing the producers and consumers of data closer to the data. Closer to the compute. So which in some terms is a networking problem. Now there's a latency that is increased as you get further away. In other terms, it's a capacity or scalability question. So the more you distribute your compute, the more compute you can throw at problems. Just a way to scale the entire system. And I think it's something that's super interesting. As you get to the edge, you have space and power constraints that mean those hardware accelerators that give you the ability to push packets or run an inference workload or whatever it is that you're trying to do become really critical because you're talking about a minimal power and space envelope. So, heterogeneous compute becomes a really important topic, which is now you're not just talking clusters of servers, but you're talking clusters of heterogeneous hardware and even directing application workloads to the right types of hardware, which introduces a whole new interesting set of challenges. So the key value store question. Kubernetes is about labels and how do you do labels, and then label-based policy enforcement, which includes directing traffic and directing applications to the right location for the right reasons. And we're building all the fundamentals that start to enable us to start to solve that problem, which I think is really exciting. I find it really interesting. And I would have said in the past it was an inevitable outcome that we would push what we've done in software-defined networking and CPUs back into hardware, because if you look at 100 gig networks, which aren't fast anymore, by the way, that's mind-blowing right there. 100 gig networks, the inner packet spacing between packets gets so small, measured in nanoseconds, that you literally only have a couple of CPU cycles to touch the packet. At that point, it doesn't matter how creative you are. There's only so many things you can do with like 3 assembly instructions.
Yeah, like physics matters at this point.
Starting to hit the boundaries. And so we were gonna hit this place where we would need to offload things back into hardware at some point, and we're hitting that place now, and it just becomes exaggerated when the application workloads themselves are changing to be more data centric, and we're distributing those workloads to a more complex topology, which also gets at, well, what is a cloud, and who did we centralize everything to the public cloud, and now we're decentralizing everything back out to the edge, and that's the pendulum that's swinging? Or do we even own our edge infrastructure, or are we just leveraging somebody else's, and it's this big commodity utility? A lot of, and not necessarily all of those are new concepts. Grid computing is quite old. Utility computing, quite old. So the thing that's definitely emerging is the amount of data and the number of connected devices are clearly going through the roof. And we have to do something to manage that. And what we'll do is throw more hardware at it and distribute the hardware and hope that we figure out how to connect it all back together.
And make a bigger network. Yeah. But as you're saying this, the commonality, go back to the beginning of our talk where you were talking about how VMs and then microservices exploded and put a heavier burden on the network underneath it to connect all that stuff together. What you just described is a similar thing, right?
Yeah, without a doubt. And there's another weird one that's COVID's fundamentally changed our lives. I don't think that's a temporary situation. I think there's permanence to that, and mostly I think that's permanence in the good sense of it's forcing us to look at how we as humans distribute ourselves. And the obvious downside is this: we're not able to hang out at a conference and have a beer together the way we would have in the past, at least not as easily. But the upside is there's a lot of flexibility in our personal lives and choice about where you live and how you work, and all those things I think are actually great for people and for the environment and a bunch of different reasons. But we're going to require something really new out of the network. The base physics says we used to have big pipes going to big buildings, and they were really busy from 8 to 5, and now they're empty, and those network flows are all starting and terminating at our homes.
Yeah. So
there's a basic physics redistribution of the network. And then there's the more we're distributed and the less we're able to sort of shake hands and get the really subtle human connection pieces, we're going to have to rely on something else. And I can only imagine exactly what that looks like. But in 10 years, we'll have sensor instrumented clothing, and we'll be able to get augmented and virtual reality, and it'll just become a norm. And some of those physical separations might feel less like emotional separation. You feel more connected to the people. And I don't even know what that means. I don't even know what that looks like, but I know that the network's going to play a central role in that. And I know that distributing compute is going to play a central role in that. Which means I think we have a really exciting decade ahead of us. And, can't wait to hang out in person and drink a beer. But in the interim, we can do this and
This is
and
what we
see how
do,
that
yeah.
drives the future forward.
I mean, what you're describing reminds me of one of my favorite songs from way back when is called Permanence and Change. And what you're describing is exactly that. You know, it's different, but it's not worse. It's different. We'll figure it out, you know, and yeah, that's a cool way to look at it. Adapt. Change or be changed, right?
Yeah, I love the positivity as well. You gotta make the best out of it, right?
It's good stuff.
I mean,
We've figured it out to date. We'll figure it out again, you know.
we
We need
will.
to stay engaged. Keeps you young. Keep learning.
Stay in school.
Hey, kids, stay in school.
Stay
The
in
kids
school.
aren't in school. They're at home.
Cool. Well, with that in mind, you all have any closing thoughts? Any last questions, comments before we wrap things up? We're at the kind of the top of the hour for a thing. We will have you back for sure. Don't worry about it. We just have to. We have a little limit on the time sometimes.
The initial conversation, yeah. There'll be more.
And I want to learn, since we have an expert, I want to learn everything there is to know about service meshes. We didn't get to talk about eBPF and XDP, which is super fun technology in Linux. So we have plenty to talk about for the next conversation.
And Kyle is officially changing his name to Kyle Meshtury.
Kyle Meshtury.
Perfect.
Yes.
We're never letting Ward on the show again after that.
After that, that's Kyle's new Twitter handle, Meshtury.
Nobody loves service mesh more than Kyle. Now, thanks, Chris. I mean, I'll just throw out from a personal note. I've learned some people like Chris, they're true innovators of our time, change the way I look at network, and anybody around them has looked at networking. And it's it's people that have built systems from the ground up for years. You know, anytime you get a chance to look at any of his recordings, I highly recommend everybody go out there and do it. It's on top of being one of the nicest guys you'll ever meet, he is one of the true innovators of our time. So yeah, thanks for coming
definitely
on.
got me to think about things differently too. Remember when we first met? You went to the IETF meeting. I was like, who the hell was this weird Linux guy?
I'm never going to forget the first time I met you way back in 2012 at that OpenStack Summit in Boston. And I remember you were both standing in the back of the room, and I knew who you were. And I'm like, oh my God, that's Chris Wright, the kernel developer. And I went up and introduced myself to you. And what's, really, I'll always remember this, just how nice you were. Some random guy just coming up and spending 5-10 minutes talking with you. And I feel like that engagement not only kind of built the friendship that we have, but you're still that same guy. I feel like I can just come up to you and talk to you anytime. And so yeah, you're truly one of the great guys in the industry, Chris. I like that.
I appreciate that. My wife would agree that anyone can just come up and talk to me.
Yeah.
And that's the challenge.
Well, yeah.
And I'm never like, aren't you coming home soon?
We're all swarming you with our questions. But I echo the same sentiments as everybody else. I remember when I started working at Red Hat, I said to my wife, look, this is the first time my boss has actually got a page on Wikipedia. Chris is legit.
Literally, that was going to be a zinger I was going to throw out for you now. I love it.
Nice. We've got to figure out. We've got to figure out at some point, Chris, how to extract how you went from weird kernel developer to CTO of Red Hat, because that's a pattern that I think I would love to follow.
Must be reproduced, yeah.
Yeah, right. We've got to figure out how we reproduce that.
That's awesome.
Maybe a seminar or something, something like that. Future podcasts.
Write a book.
Write a book.
Go on tour. This will be fun.
Cool. Well, thanks.
For all the words and the invitation to be on the show. I really enjoyed it. I love hanging out with you guys, so appreciate it.
Yeah, thank you for taking the time to be on today. We really appreciate it, as evident from the talk today,
fun.
And it was super fun. And hopefully we can have you on again in the future to talk about some of those other cool topics. So thanks again, Chris.
Cool.
We'll see you soon.
All right. Later.